I tried to turn a small script into a real product. And that's where things started to get interesting. In part 1, I wrote a Python script to clear out years of inbox clutter. And while it worked, it wasn't really something that I could share out with someone else without it turning into a whole setup. The script was good enough for me, but if I wanted someone else to use it, this really wasn't the best solution. It needs to be easy to set up. It should look intentional. And it needs to feel like something people can trust. Maybe I could build a Chrome extension. The Chrome extension will need to have the same functionality as the Python script, with some extra features. We'll need input fields for the search terms. Before deleting anything, the user needs to see what's about to happen. So we'll also need a preview window. And we'll need 2 action buttons, preview and trash. Preview pulls matching emails and lets you scroll through them. Trash only happens after that. And then, once you click trash, there's a progress bar so you know what's happening. And also a cancel button, or a panic button, in case you realize you're accidentally deleting important emails and you want to abort immediately. This isn't just about deleting emails fast, but it's also about deleting them safely. Okay, so since this is essentially a front-end app that calls an API, let's start with the most obvious piece, which is the front end. Once all the components are built, then we can start wiring up the rest of the stuff, like authentication and the API. For the front end and logic, I'm using the go-to stack, React and TypeScript. And since I'm intentionally trying to make the UI look Google-esque, the styling is pretty simple. Pure CSS does the job pretty easily. No frameworks needed. As the UI components started to come together, I realized that I needed to add 2 toggles to provide the option for either excluding or including starred emails and those that are labeled important. I kept working at it for the rest of the day until the UI was ready. Before writing more code, I want to understand exactly how this app flows. First, authentication. Just like how we did in part 1, the user signs in with Google OAuth. This gives the app permission to access the user's Gmail account through an access token. Since this is a Chrome extension, we'll also need to use another API, which is the Chrome extension API. The user will start off by entering inputs that forms the email search query. And after this, they will click the preview button. This will trigger a GET query, which contains the email search parameters to be sent to the Gmail API. This will pull back matching emails with unique email IDs. Those emails will be displayed in the preview window with the relevant metadata for the user to review. Once the user is ready, they will hit the trash button. This will take the email IDs we pulled, construct a sequence of post queries to be sent consecutively to move these emails to trash. If the user changes their mind mid-job, then they can simply hit the cancel button and it will interrupt the whole process. I think that should be all I need to build a functional MVP. Cool, that makes sense. Let's get back to coding. Everything worked until I tried deleting more than 30 emails. This is the rate limit error. It basically means that the server is saying you're sending way too many requests. And it didn't happen with Python, which is when I realized Python spoiled me. The Python libraries were quietly doing something smart in the background. They space out requests, they add randomness. It's a strategy called Exponential Backoff with Jitter. And in TypeScript, I had to build that myself. So here's how I think about it. So imagine you're trying to call your mom and she is already on another call. You try once, no answer. You probably wouldn't keep trying every 5 seconds. You would wait for a little bit. So maybe you'll try again in 10 minutes. Still busy. This time, you wait longer, maybe 15 minutes. Every time you fail, you increase the time you wait before trying again, giving her, eventually, enough time to free up the line. That's essentially exponential backoff. We send requests to an API, like the post requests to Gmail, and the server says, hey, slow down. We don't want to immediately retry. We wait and retry, and if it fails again, we wait a bit longer. Now, here's where Jitter comes in. Let's say your dad is also trying to call your mom, and he ends up using the exact same strategy. Retry after 10 minutes, after 15 minutes, after 20 minutes, and so on. If both of you retry at the exact same time, then you'll keep colliding and none of you will get through. So instead, you introduce a little bit of wiggle or randomness. Maybe you wait 13 minutes instead of 15, or 22 minutes instead of 20. That small randomness spreads out the calls so that one of you can actually get through. That's Jitter. So exponential backoff slows you down, and jitter makes sure that everyone isn't retrying at the exact same times. And once I implemented this strategy, things started working as expected. So let's go and look at the demo, shall we?
No way.